Hey guys, today we'll discuss about the PDF, PMF, right, and CTF. What is the PDF, PMF, and CTF, and how it will work, and what is the application in data science? So first of all, we understand the probability distribution function. Probability distribution function, right? First we understand about the probability distribution function. Okay, probability distribution function describe how the probability are distributed over the value of random variable, right? I'm not write definitions in my board because this board is too short, so please keep understand. Okay, so probability distribution functions describe how the probability are distributed over the value of random variable, right? We are considered as a random variable, random variables, random variable is example age, right? Age, and we have many data points. So how this data points work, and how we are use that's a random variable for the probability distributions, right? So we talk about the probability distribution functions. There are two types of probability distribution functions. First one is uh, probability mass function. And it's used for the discrete random variable. Discrete random variable, right? Probability distribution mass function is used for discrete random variable, nothing but PMF, right? And second one is a probability density function, right? It's used for continuous random variable. This is the two type of probability mass function and probability density function, right? So let's clean up. That's two type of probability functions, and we will understand about the first what is the probability mass function. Probability mass function. Probability mass function, right? So and let's get example and understanding about the probability mass function. First example is that rolling a disc, right? And that's what is of output. There is nothing but we talk about the output is 1 2 3 4 5 and 6, right? And what is the probability of 1? Probability of 1 is 1 by 6. I hope you understand the probability. We will understand this in a previous video. Similarly, probability of 2 also 1 by 6. Probability of 3 also 1 by 6. This is a discrete random variable. It means one outcome is not affected the another. If we are roll the disk and it's come, and it's another time we are doing the same things, so not affected one output is to the another output, right? This is nothing but probability of that segments. So if you talk about the PMF graph, so your graph is look like a 1 2 3 4 5 and 6. Similarly, in that is a 1 by 6, 2 by 6, 3 by 6, 4 by 6, 5 by 6, and nothing but 1. This is the x-axis and this is the y-axis. Okay, so we talk about the probability of 1. So what is the probability of 1 is nothing but 1 by 6. Similarly, probability of 2 also 1 by 6, probability of 3 1 by 6, probability of 4 1 by 6, all are same. So if your graph is look like that. If you similarly we are a draw of a CDF we are a draw a graph for a CDF. So let's understand about the CDF. This CDF is nothing but, okay, first of all we understand about the CDF, right? What is a in a CDF graph of a probability of x less than equal to 2. So what is the probability of 2 is probability of 1 plus probability of 2, right? This is a CDF for CDF for CDF. And if talking about this graph of this, so we have graph look like this. So 1 2 3 4 5 and 6. Similarly 1 by 6 or 2 by 6, 3 by 6, 4 by 6, 5 by 6 and 1. So your graph is continuously increases. So your graph is look like something like that. Probability for 1, probability of 1 for that, then 2 by 6, 3 for 4 5 and nothing but 6. This is a graph for a CDF. And what is the probability mass function for graph is look like this, but for CDF different. I hope you understand about the CDF, right? And we will learn about a probability density function in a next video.